Hello everyone, welcome to Reactify Labs. Today we will talk about the low level design of a parking lot. Okay, so it's parking lot. Let's name it LLD parking lot to keep it uniform with other videos in the playlist. Okay, so we will see the low level design of parking lot. So parking lot, as the name suggests, it's a lot where you park. Okay, and you may ask, why do we need a system design for a parking lot, right? Because if you see mm, the parking lot of your buildings, they don't need anything, right? But if you go to some big malls, right, there there is a continuous inflow and outflow of vehicles. So there they need something to manage the traffic. Similarly, if you go to your office buildings, let's say if your office building has 100 floors, it means there are a lot of cars, right, or bikes. So there they need a way to track the parking space so that new parking spaces can be allocated to new vehicles, or if they need to make additional parking spaces, a lot of decisions need to be made. Okay. Mm. But the best example would be some very big mall, some big shopping mall, so which has the continuous flow of traffic. Because offices, if you see, it has like in the morning a lot of people will come, in the evening a lot of people will leave, and throughout the night it will be empty, right? But in the mall it's like there is a continuous flow of traffic throughout the day, with majority of flow during the evening, right? But otherwise it's throughout the day. Usually on the weekends it's a lot. So parking lot is needed in those kinds of scenarios. Okay. So uh, yeah, now that we know why parking lot is needed, let's see what all are the requirements of parking lot. First of all, due to the limited space, you cannot extend the parking lot by uh, a huge area in one floor, like ground floor or first floor, right? So you need a multi-floor parking, correct? So the first requirement would be our parking lot would be a multi-floor parking lot. So we will write the requirements. So as I have told you in my earlier videos as well, always start your designs with requirement collection, because your interviewer is only going to tell you that you have to draw a parking lot. He will not tell you that you have to have a multi-floor parking or you have to have a parking for truck also. He won't tell you anything. It's your job to figure out whether you need a parking for a truck or not, or what kind of features do you want in this parking lot. Okay, so it's your job. So you have to talk with the interviewer. The system design interview is usually a two-way conversation. Okay, usually in the start it's a two-way conversation. After gathering all the requirements, maybe you can do a monologue, but most of the time it will be a two-way conversation. So talk to your interviewer and gather the requirements. So for the sake of this video, let's gather the requirements now. It will be a multi-floor parking lot. Multi-floor parking lot. Hmm? Next, it will have multiple entry and exit points. Multiple entry and exit points. And an exit point will be different from an entry point, because otherwise it's not a decoupled system, right? Other thing is, we will have multiple entry points and multiple exit points. Otherwise, only one will be a bottleneck. Hmm? Next, we have to have a mechanism for ticket collection and payment. Mm, So, ticket collection, payment, correct? So, customers collect a parking ticket from entry points. Payment can be made at automated exit panels to parking attendants or customer info portals. Anywhere it can be done. Either you can pay at the time of exiting, or you can pay online also. Okay. Payments can be made via cash or credit card. Hmm? So a lot of things can be gathered here also. There you have to talk to the interviewer to gather your requirements. So maybe you can use cash for payment. Maybe you can use credit card for payment. Maybe you can use debit or credit. I will keep it as same in the card. Okay. So yeah, mm, you can pay it online or offline, but that is something we are not going into much granularity. Okay. You may have something like a capacity management. I mean, you need a tracker to track how many spots are empty of what kind of vehicles. Like, uh, if the spot is available, but the spot is only for bike, you cannot park a car there, right? So, capacity management is essential. Next, you have to have information about parking spots. Hmm? So, support for different types of parking spots, like a compact car, a large car, handicapped, motorcycle space. Okay. Each parking floor should have a display board showing available parking spots for each type. So before you enter, let's say you are trying to enter this parking lot. So you should know, actually here, you should know if there is available space or not for your kind of vehicle. So there will be a display board at the outside. Okay. And the person who is there, that person will know if the space is available or not. If that person sees that yes, the space is available, that person is going to give you a ticket. So in which floor are you going to park it? So each floor need to have this information so that you know which floor you have to enter. Otherwise, if you keep going through the stairs and if you enter one floor and the parking spot is not there, you will have to again come back and go to the next floor, right? So to avoid that, we will need a display board at the entrance of each floor. Okay. Next, we need to have some parking fee model. Parking fee model, like, for car this is the price, for bike this is the price, for first hour this is the price, for the remaining hours this is the price. So all these things should be incorporated in your parking lot. So this is the requirements collection, like multi-floor parking, different entry and exit points, ticket collection portal, payment portal, capacity management, parking spots, parking fee model. Is there anything that I'm missing? We have a parking spot, we have a parking rate, we have, yeah, yeah. I think we don't do anything else than this, right? If you are confused or if you are not able to figure out, just think, if you go to a place and you decide to park, you have to park your vehicle, what all things need to be handled, right? You should know which floor to go to, you should know what is the price of the parking, you should know what kind of spots are there. Maybe you take your truck, right? Not the pickup truck, it's actual truck. Are you allowed to park that? No, right? So you have to take all these things into consideration. Maybe you go with a train, maybe you cannot park train. I'm not sure, maybe some malls have that. Okay. Now that we know these things, we have the requirements, let's see what are the use cases that we can find here. Okay. And who can do what. So if we talk about use cases, so the use case is, let's say, somebody, not only you, like somebody should manage the parking spot, right? Let's say there is an admin. So what admin can do? Admin can add or remove a parking spot. Admin can add or remove a parking floor. Let's say there is some restructuring of the organization, like they need to open something else there or open a warehouse in one of the floors, so they will have to close that floor for parking. Or let's say they have reserved 10 floors for parking, but they don't get those many vehicles, so they will just let go of the 4 floors, because the amount of traffic that they get can be handled in only 6 floors. Next is, let's say there is a parking attendant there. So what does a parking attendant do? The parking attendant gives you the ticket at the entry. The ticket has an entry timestamp. So somebody can add or remove that parking attendant also. Parking attendant, because let's say the parking attendant left the job. So somebody needs to remove that person from the system. So a new parking attendant joined, right? Right. Next is somebody needs to take the ticket. Take ticket. There will be a mechanism to scan ticket also to check, like when you enter, you take ticket. This ticket has the time of entry, type of vehicle. Let's say either it's written there or it's encoded in a barcode. Okay. And when you exit, this happens, scan ticket. Okay. When you exit, the ticket is scanned. So this scanning, like let's say they do the barcode scanning. So automatically what this barcode scanning does is it gives you all the information, like type of vehicle and time of entry. And from the current time, it calculates the duration of your stay and automatically gives you the total final price. So this is why scan ticket is required. Okay. Next is payment. Let's say you pay using a credit card. Credit card payment. Next, let's say you pay using cash. And you have to update that information in the system, right? If somebody pays you by cash, you will update that in the system that yes, I received this much cash, so that the book is clear. Parking rate. Add or modify parking rate. Let's say yesterday it was $4 per hour and today it becomes $5. So somebody needs to update this also, right? This is also one of the use cases. Or let's say till yesterday there was no support for EVs, right? But today we got an EV support. So we need to add the charges for this EV also, right? Because most of the time what happens is if there is an EV parking, a parking lot, charging point is also associated with it. So this is also necessary, like that EV will charge as well. So the parking rate should be accommodating that also. So these are the different kinds of use cases that I could think of for a parking lot. Okay. So now that we have to make a class diagram, we have this requirements clear, we have our use cases clear. So we make our class diagram. So before class diagram, let's list down what all classes are we going to need. So all the classes that we are going to need, we have to take into consideration solid principles like single responsibility, open closed, list of substitution. This is, I forgot, D is dependency inversion, I is interface segregation. Yes. So we have to take all these into consideration while deciding classes, because we cannot merge everything in one. We have to try to make our system decoupled, right? It should not be strongly coupled, it should be loosely coupled, right? For an example, let's say I give you one example. There is a parking lot. Because we are making a parking lot, there will be a class called parking lot. And there is some, let's say we make it like we give the parking lot an ID, it has a location, and it has a we'll say car spot, it has a bike spot, it has a EV spot. So this is not a good design, right? Because this spot is not the same as parking lot. This spot should have its own class. And if this spot should have its own class, it means there should be another class called parking spot. Why? Because let's say tomorrow, if we decide that yes, we have got very rich and now we allow train parking also. So we have a train spot. So if we add a train spot, what happens is we are modifying this class, which violates the O of solid. O says open close principle. This class should not be modified. It should be open to extension, but not for modification. It should not be modified, right? So that's why you cannot add a train spot here. So what you can do is you can add a train spot here in your parking spot class. And also this spot is completely different from parking lot. So this violates the single responsibility principle also. Why am I giving the responsibility of a spot to a lot, right? So that's what our design should consider. So our design should be as decoupled as possible. So let's list down the classes first. So we will have a parking lot class. This parking lot will consist of a lot of things, including a parking floor. Okay, there will be a parking floor. There will be a parking rate. The parking rate belongs to a parking lot, not a parking floor. It's not like, okay, for this floor the rate is less, for this floor the rate is more, because otherwise everybody will want to go to the floor with the cheapest rate, right? And that would also have become like too difficult to manage, because different floors have different rates, too many variables, right? So to keep it simple, parking rate belongs to a parking lot. Okay, so each parking floor will have a parking spot. Each parking floor will have a parking spot, because a spot is identified by which floor it belongs to and what number it has, right? Two things. If only we give a number, let's say there is a very big parking lot, we give it 1113, and people will keep on searching where is 1113. So having a unique number at each floor helps people identify that, okay, I need to go to this floor, then I will search for it. Okay, somewhere it's also like, in this floor, go to column A, then go to this number, or go to column C, then go to this number. So this is also another good approach, right? So that's why a parking spot basically belongs to a parking floor. Okay, now that we have these things, what else do we need? Now, our parking spot will have different kinds of vehicles, right? So different kinds of vehicles. It can be a car, it can be a van, it can be a motorbike. So there will be a vehicle class. So vehicle class will have different kinds of vehicles, like motorbike, we have a car, we have an EV. Okay, we have different types of vehicles. Next, vehicle will be another class. Next, there will be an entrance panel, right? So entrance panel will be another class, and which will belong to parking lot. Entrance panel is another class. So each panel will have an ID. Let's say there are 4 entry panels, so there will be 4 IDs, so that it knows which from where you entered. There will be an exit panel also. Entry panels and exit panels belong to parking lots, not on the floors. Okay, and as I said, each floor needs to have a display board. So there will be a display board also, which belongs to a floor. There will be a display board on each floor. And since display board will be on each floor, and display board itself has a lot of information. Let's say today display board displays date, time. Tomorrow, let's say it changes to display date, day and time, which day of the week it is. Next time, let's say we need to change it to make it like date, format of the date changes. Let's say now it says, earlier it was DDMM, now it's MMDDYY. And then day, time. So this needs to happen independently, right, in the display board. So we cannot add display board to parking lot, because the display board is at a parking lot. So let's insert the functionalities of display board in the parking lot, parking floor. No, we cannot do that. We have to keep display board as a separate class. That's why we are keeping display board as a separate class. Okay, so that's what display board is for. It will have a lot of information, like that date time I just gave for example. Usually it will contain information like how many spots are available for each kind of vehicle. Okay, and other than this, as somebody enters, that person will get a parking ticket. So that parking ticket will be another class, right? And when somebody exits, that person needs to make a payment, right? So the payment will be another class. Why? This payment should be separate from parking ticket, because parking ticket is given to you, parking ticket has its own functionalities, features, and payment should be separate because payment is completely different entity. Payment does not have anything similar with parking ticket. Hmm? So the payment needs to be done for the parking ticket, right? So payment will be itself in itself a separate class. And to keep two kinds of payments, like credit card payment and cash payment, it will also have two types, like credit card and cash. There will be two types of payments. So yeah, uh, payment is also figured out. So basically it's like this, a payment can be an abstract class and credit card and cash will be its implementation. So depending on our use case, we can make it like that. Okay, now that we have covered most of the things, anything else that's left? We have a lot. We have floors, we have entrance, we have exit, we have spots, we have tickets. We have covered most of the things actually. Okay, so there is one thing which we can add. Actually, we should add it. Uh, as I said, there will be a parking attendant, right? There will be a parking attendant. There will be somebody called admin also who is going to add or remove the parking attendant or add or remove the floor. So this admin and parking attendant, they both will have a lot of things in common, like the name, address, email ID, phone number, a lot of things in common. It's just that the admin will have some special privileges. So they both should inherit something called account. So the account will have some common information, maybe some abstract class or an interface, and the others can inherit from them. So yeah, these are all the classes that we are going to need. I don't think we need more than this. So now that we have our classes ready, 5, 6, 7, 8, 9, 10, 11. We have our 11 primary classes ready. So let's make our design. Let's make our system. So we will have a parking lot. So we will have a parking lot first. This parking lot will be identified by, let's say, an identifier, and it will have a location, location or an address, whatever you say. So this will be a parking lot, and parking lot will have a parking floor. So parking lot will have a parking floor. So parking floor is identified by, let's say, the floor number. This floor number. And if you see, parking floor cannot exist without the parking lot, right? So it will have a composition. This will have composition on parking lot. So parking floor will not exist if parking lot does not exist, but parking lot can exist without parking floors. Great. Next, as I said, each floor will have its own parking spot. So again, parking spot will depend on parking floor. If there are no floors, there will be no spots. So it will be parking spot. This parking spot will have a number. Parking spot will have a parking spot number attached to it. Parking spot will have something called occupied. Is it occupied or is it free? Occupied means it's a Boolean variable. If it's true, it means it's occupied. If it's false, it means it's empty. It will have a type also. What type of parking spot it is? Is it for car? Is it for an EV? Is it for a bike? Right? A lot of things. And basically this type will belong to, let's say, the vehicle type kind of thing. And we can make this vehicle type an enum. So basically what we can do is we can make a separate enum. We will keep enums here. So v type, this is an enum, and it will have let's say motorbike, car, and EVs. Okay, So this is what an enum is. So instead of writing it, the best practice in software development is to assign it an enum so that you can take it from there, because the values are limited, right? So we can just take it from there. So the type is defined now. We type. Now next what? Each floor has parking spot. Now each parking spot will have a vehicle, right? So basically this parking spot has vehicle. So first we will make a vehicle class. Let's say this vehicle class, and this vehicle class will have again the vehicle information, right? Like the number of the vehicle, number plate, whatever it is, and the type of the vehicle it is. Okay, this is the vehicle class, and this parking spot will have an arrow attached to it. There will be an arrow from parking spot to vehicle, and that arrow is called association, unidirectional association. It means this parking spot will have vehicle. Parking spot class will have an instance of vehicle, but vehicle cannot have an instance of parking class. So that's unidirectional association. Now that we have a vehicle in the parking spot, what else is left? So if you see, we are done with parking lot, we are done with parking floor, we are done with parking spot, we are done with vehicle. Now we have parking rate. So the parking rate, as I told you, it belongs to parking lot. So if parking lot does not exist, parking rate does not exist. So there will be a parking rate which will have like rate, whatever the rate associated with it. The rate will be associated with the parking spot, not spot actually, parking lot. Depending on the type of vehicle, the rate will be determined. And this will be again like this composition, because if parking lot does not exist, there is no question of the existence of rate. So now that we have made rate as well, let's talk about this entrance panel and exit panel. Again, this entrance panel and exit panel belongs to the parking lot. So we will make entrance panel, we will make exit panel, and each of these will have some information associated with them. Let's see what. So the entrance panel again will have nothing, just an ID, and exit panel will again have nothing but an ID. Each panel will have their own identifier, and they will all belong to this parking lot. Why? Because they will not exist if the parking lot does not exist. Great. Now that we are done with entrance panel as well and exit panel as well, now we have display board. That display board, as I told you, will be on each floor. So this display board, and it is on each floor, and if the floor does not exist, there is no question of display board, right? So again, composition. Okay, and display board will have what? Display board again will have let's say floor number to show which floor it belongs to, and along with this it will have like motorbike free spots, car free spots, EV free spots. So free spots for each kind of vehicle. Okay, so even display board is done. Now that display board is also done, the only thing left is parking ticket and payment. So the parking ticket is associated with again a parking lot, right? But there will be other things associated with it as well. So let's make it first. There will be a parking ticket. This parking ticket will have a number on the ticket, a time at which it was given. There will be some things like, let's say, type of vehicle. So these things, let's say, are associated with it. So the time at which it was issued, the type of vehicle, and number. Along with this, you can identify the ticket. Okay. So this parking ticket is associated with a parking spot, because obviously this you cannot use the same parking ticket to another spot, right? So this parking ticket is linked to a parking spot. Hmm? And the thing is, what all will contain this parking ticket? If you see, entrance panel will contain this parking ticket. Entrance panel need this information of parking ticket. Vehicle needs this information of parking ticket. So there will be a unidirectional association between vehicle and parking ticket. There will be a unidirectional association between entrance and parking ticket, and one between exit and parking ticket. So these links will be there because entrance panel will contain the parking ticket information. It will have an instance of the parking ticket, right? Okay. And then parking ticket, if you have got a parking ticket, you should pay it, right? So you have to make a payment of the parking ticket. So payment will have like the date, time at which the payment was done, the amount for which the payment was done, and also the status if the payment was successful or not. And the payment has association with parking ticket. So like the payment will have an instance of parking ticket, and the parking ticket will have an instance of payment. And this payment will have two children, right? One is credit card transaction, and one is another one is cash transaction. So it will have the same things like cash will have amount, how much amount in cash was provided, and in credit card it will be like maybe the card number. Actually the card number is not the right thing to store. Maybe last four digits of card number, or the name on the card number, anything is fine. Okay, so if you see, our system is more or less ready. Now let's see what all things we are missing. So if you see the vehicle, there is vehicle, we have a type of vehicle, right? So again, this vehicle type, if you see, okay, we have made an enum for vehicle type. Then we have where is it, parking spot. Okay, the parking spot also has a type, the vehicle also has a type. So maybe we can use the same enum for parking spot and the vehicle. Okay, now as I said, there is a status on the payment. In the payment there is a status, so maybe we can make another enum for status. Payment status. So let's say payment was successful, failed, on hold. So a lot of things can be there with the payment status, right? Okay, now next, as I said, we missed account. So let's create an account class as well. So we will have an account class. So the account class will have let's say the email ID, password, and status of the account. Is the account active? Is the account not active? And this account will have again will be extended by admin and attendant. So the they will extend it like this, and that's it, right? But attendant can issue parking tickets, right? So attendant can issue parking tickets. So attendant has a unidirectional association with parking ticket. So if you see, this system is more or less complete in itself, but there are still a few things which are missing here. And those few things are like, what are the functionalities of each of these? So for example, let's say this attendant, what is the job of this attendant? So the job of each class will be the functionalities. So it will have method. For example, let's say if there is a class, what all things class has some variables, like let's say if you have a calculator class, you have some variables, right? Like int x, int y. Then you have some methods like find sum, find product, right? So we have made these, oh sorry, what happened? So we have made these int x, int y, if you see all the classes, but we have not provided these methods that will be there with the classes, so which are important. So we have to provide methods as well. So for attendant, if you see, the job of the attendant is to process ticket, is to process a ticket. So for that, he is responsible, he is interacting with parking ticket, right? So this process ticket is the job of the attendant. So this method should be included with the attendant. So if we write it like separately somewhere, first let's say attendant, get ticket or process ticket. So this is the job of the attendant, to process ticket, right? Admin, as I told you, admin, what it can do, let's say update parking floors, update parking spot, one method. Update parking floor, other method. It can have also update update attendant, update as in both add or remove. Okay, so these kinds of methods will be there with the admin. Next, what other things we can have? Let's say there is a parking spot. So if there is a parking spot, how do you check if the parking spot is empty or not? So let's say there is a method is occupied, is occupied. So basically you will call this method on the object. So basically, if you, what do, you make class, right? You make a class of parking spot. So you make an object parking spot p, and if you have to check it, what you will do, you will check p dot is occupied. Okay, like if p dot is occupied means if it is occupied, return false or return some string not available, else available, something like this, right? So basically I'm not trying to write code, I'm just showing how it's used. So this parking spot will have some method like is occupied, correct? Next, if we have a vehicle, so vehicle, what method will vehicle have? Look, like a ticket is associated with a vehicle, right? So a vehicle will have some method like get ticket. So the vehicle will have something like get ticket. Next is let's say let's go to parking floor. So parking floor, it will have some methods like, let's say add parking spot. Actually no, not add spot. Basically we can have something like if a car is or a vehicle is entering and vehicle is leaving, so maybe we can have one update for both, but actually it would be better if we have something like free spot. This method will free the spot once the vehicle leaves that place, or occupy spot, occupy spot once a vehicle goes to that place. We can have something like update display board, because for each parking floor there is a display board, so update display, these kinds of methods, right? Okay, next, what else is left? So parking lot can also have a few things. Let's say we have parking lot. The methods that it will have is add floor, because everything belongs to a parking lot, right? So add parking floor. It can add some doors, some exits or entrances, so add entrance. It can have another function, add exit. It can also have some function, because at the parking lot you will get a new ticket, right? So you can have a function like get ticket here. You can also check at the entrance only, as I mentioned, you should know at the entrance if the parking spot is available or not, so that people don't just go round and round to check every corner of the spot only to find that there is no spot left. So you can check is empty. So is there any space empty? If not, you can tell them, you can tell the newcomers that please leave, we don't have any space left, right? So these are the important methods that are required. So yeah, these are all I could think of. I don't think there is anything else, or if you find something you can add them, right? Just make sure that it follows solid principles. Your method should belong to the classes where it should be in the classes where it belong. Okay, like if parking spot is occupied or not should not belong to parking floor, because it's the question of a spot, if that spot is occupied or not. So that should belong to a parking spot, right? The responsibility of the parking floor is to tell if any spot is free or not. If any spot is free, it's the responsibility of that spot to tell that, okay, if yes, if I am free or not. The parking floor just gives the high level overview that yes, some spots are empty. So these are the things that need to be taken care of. And yeah, I've covered most of the things. And as I have mentioned in earlier videos as well, this this LLD playlist that I have started, this is not going to cover any code, because I know you can write code. If not, you can always refer to some maybe ChatGPT or something else that yes, give me this code. You can do that, right? But what's important is this: you should know how to make classes. You should know how to gather requirements. You should know what all functionalities you need to cover. You should know what all classes you are going to make and what are the responsibilities associated with each class. And once you have that clarity, it's just a matter of rearranging the letters of the English alphabet here and there, like class this, class that. You have everything, right? You have class, you have the variables, you have the methods, and you know which class will have the instance of which class. So you can easily make it. So yeah. And also again, in the low level design interview, you are not expected to write code. You are judged mostly on if you are able to make these classes, you are able to separate concerns in their respective classes or not, if you are able to first gather the requirements properly or not, if you are able to come up with the use cases or not, then if you are able to come up with different classes or not, then after that, like, half of the job is done till this point. After that, are you able to link the classes or not? And if you are able to link the classes, almost most of the job is done. If the interviewer then asks you to write a code, it's just a formality. Okay. If let's say the time is left, then only the interviewer will ask you. And maybe sometimes what happens is they may ask you to write a code for one of these methods, just to check that if you can actually write code or not. Okay. So they will tell you that, okay, tell me if I have to do something like get ticket, what will you do? So for a vehicle get ticket, you can just write a logic that get ticket will be followed by a lot of things. So first you will check if the spot is free or not. So actually first you will start with this. In this parking lot, you will check if there is any slot empty or not. Yes. Then on which floor is it empty? Then in that floor, what kind of space is there? If the space for that particular kind of vehicle is there or not. Yes. Then you get the ticket, and after you get the ticket, you have to update that display for that floor. Okay. And you have to update the parking floor also. No, sorry, not this one. You have to update the number of empty slots on that floor, like this one, free spot. You have to update that as well. So this is something you can do. Like you have to make sure that when you implement any function, you should cover all the dependencies which should come with it. Okay. So yeah, that's all there was in this video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next video with some other system design. Okay. Thank you.